finally, we're done chapter 6, we're done quadratics, and we're on to the last unit, which is trigonometry. Okay, so we're going to start off with similar triangles. Now, similar triangles are basically when you have two triangles, they're exactly the same, except you have one that's smaller and one that's bigger. I want you to notice that each of the corners are the larger letters, they're capital letters. And each of the sides opposite of the larger letters is its small letter, and that describes this base length. Okay, so the length of A, little a, is the same as, or you can also call it by the two big letters. Okay, so just the same, this is little b, it's across from big B. You could also call it side AC. It's really up to you whether you want to use the little letters or the big letters. Okay, now the other thing I want to discuss is these curving lines. They're just saying that angle B matches angle E in the other side, and angle A is the same as angle D in the other triangle. The reason why they're saying this is because if I spin, say, the blue triangle around, I want you to be able to orient yourself and still know which corners match with corners. Okay, so let's take a look at some formulas. These formulas are very easy to understand. They look a little bit complicated, but it's just logic. Side A matches side D, so I put them together. Side B matches side E, so I put those together. And side C matches side F, so I put those together. The ones on the top with the two letters, those are basically the same. I'm just using, okay, so BC, I'm using the big letters. Okay, and EF, all right, just using the big letters again. So they're basically the exact same formula, and you're just finding matches between the triangles. Okay, now the other formula you could use is if at any point they told you, I have area. Okay, so the area of this one maybe is 100, and you want to know what the area of that one is. Well, you can set up the same formula to kind of figure out what the area is. The only difference is when you set up your three fractions over here, you're just going to square the sides. Okay? One of the things that a lot of people make mistakes on is the fact that they kind of write the fractions mixed up. So in that case, what I'm saying is, if you have all of these tops from triangle ABC and DEF is on the bottom, make sure that you don't accidentally mix one of the fractions up. Okay, so be consistent. If you have ABC on the top, make sure it's always ABC on the top. And if you have DEF on the bottom, it's always DEF on the bottom. Okay, so we're going to go through one example. Here's an easy example. All right, so number one, triangle BCD is similar to, so that's what that line means, triangle EFG. And I want you to find E and C. Now I have the formula down there, and I'll even fill it in with the numbers that they've given me. Okay, now what's just confusing is where do all these numbers come from? Well, the 10 and the E, those are partners. So this E matches the 10. That's where this came from. Okay, and the 5 and the 4, they match too. And so do the 6 and the C. They're right there. I'm going to use each of these matches in order to figure out my answer. Okay, so let's take a look. We want to kind of figure out what E is first, and then maybe we'll work our way to C. If I wanted to find E, I don't necessarily need that middle fraction, the black fraction. I only need the fraction that has the E and another fraction that has two numbers. Okay, so notice that E is the only one that's in the equation. So I basically move that down there, and this is just right here. What I'm going to do with that is I'm just going to cross multiply. 5 times E is going to equal to 10 times 4. Okay, so right there. All right. and that's just 40. Now to find E by itself, I'm going to divide each side by 5, and I get E is 8. So the math itself is actually quite simple. It's just the setting up of the fractions. Okay, let's solve for C now. So when I take a look at C, I need the fraction with the C in it, and then I also need the other fraction that has a number in it. Now that you've found E, and you know that this is 8, you could actually use this fraction too if you really wanted to instead of the 5 and the 4. All right, so the exact same thing, you're just going to cross multiply. So 4 times C gives you 4C, and then 6 times 5 is going to give you 30, and you're going to divide both sides by 4, and you are going to get 7.5. We want to make sure that we have a therefore statement just so that everyone else understands, well, what are we measuring in first of all, and what did we actually find? Okay, so let's get rid of all this, and we'll go on to the next example. So triangle ABC is similar to triangle DEF, and they've given us some numbers in the question. I filled out the question, or sorry, the diagram, and this one asked me for an area. So I'm thinking right away, I want to use that area formula. What is the area of ABC if they've given you an area for DEF? I'm going to set those two up on top of each other, and then I'm also going to set up the other two partners on top of each other. Now remember, those are supposed to be squared. Okay, that's what's different about this formula. So what I'm going to do now is I'm actually going to put in all the numbers. So let's get rid of that. There you go. Substituted the numbers, and I'm just going to solve now. Okay, so 8 squared is 64, 12 squared is 144. Now that I have everything nice and simplified, I'm going to cross multiply. So 144 times x gives me 144x, and then 54 is going to times the 64, and I'm going to get 3,456. All right, next step, we're going to divide by 144 on each side, and we get 24 as our answer. The area then of triangle ABC is 24 centimeters squared. I hope you're starting to see that each of the questions are actually the exact same thing. Again, you're just setting up two fractions, making them equal to each other, and then cross multiplying. If we have a word problem now, just an application question, we do the exact same thing. So here is a surveyor. They want to see how wide this river is. Okay. Now, you're not going to say, hey, why don't you hold on to this measuring tape, swim across the river, and I'm going to measure how wide this river is that way. No one's going to do that. In fact, if you ever asked anyone to do that, they'd probably just run in the other direction. What you would do instead is you would actually just walk across the land, measure that distance, so that's 50. Continue to walk, so another 20 meters, and then measure this side right here, which is 24 meters. And you can easily create two similar triangles that'll help you to figure out the width of the river. Now, 20 and 50, those are both the bases of each of those triangles. 24 and your unknown, those ones match as well. If I put these into the fractions, you want to make sure they're in the right order. Okay? So there you go. I have AC. So I'm starting off with the smaller triangle, and then that's over its partner, and that equals to AB, which again, I'm starting with a small triangle, and then that's over DE. I'm just going to fill those in with the numbers, and then I'm going to cross multiply. All right, so 20 DE is equal to 24 times 50, which is 1,200, and then I'm going to divide by 20, and I get 60 meters for the width of the river. Okay, so again, this is just a tutorial on similar triangles. The next tutorial will be on the start of trigonometry. Yay!